So I got to wondering about some stuff about these shapes. So I've got this little process that I want to apply, and I'm going to apply it to each of these perfect solids. So we've got a tetrahedron, a cube, an octahedron, and a dodecahedron and an icosahedron, and they all have different numbers of sides, but I'm keeping the process the same because I'm curious to see if they produce more than one object. So I'll show you the process with the tetrahedron. So here we've got our tetrahedron. Now if I select these corner points and do identical and bevel them down, you can see what happens to the shape. So what I'm doing is I'm not going to port this shape yet. That's his link the inner to the outer surfaces, as you'll see when I generate them. I'm just going to start by doing the beveling process to see how many shapes are generated, and then look at the implications of what happens if you start putting ports in the side. So I'll bevel it down a bit. I don't need to be too precise about this. So you've got a bit of an edge remaining and this side selected. Right click and intrude that in another bit. These surfaces that are inside here, when I get it cut, will be squares. So I just need to bear in mind that when I select this edge and go identical, all these other out edges get selected, then loop. I've now looped. I'll press loop again because sometimes it doesn't go all the way around, so L for loop. I've now looped around a square, and I can go circularize, so that will even the side. Well, it was a rectangle, now it's a square. Okay, so the point of that is when I right click and loop cut, and one of these isn't left unselected, use geometry graph to hide that bit, you can see the bits that were cut. These faces came about as a result of the cutting process. So I select one of these and then bring the missing face back and press identical. So I've now got all those squares selected. I can use W to show the wireframe to show you where they are. And then I'll leave the wireframe active and use right click and rotate, hold the shift key down and do normal. So I've just rotated those and you see them twist in opposite directions. I'll put the solid shape back now, and then I'll weld it together, and then I'll do a Sabian subdivision. So at this point I am looking for these paths that go around from one object part to the other. So there's these faces and there's these paths that separate them. So if I select a edge on there and press G to propagate it round those edges. Oh, I can never remember the name of this command. It's a edge ring, right, and I for identical, so I get the ones that are corresponding on the other faces, and then select face. You can see how those faces loop around and sort of connect again. Right click and intrude. So at this point, I'll just do it an arbitrary amount. I have put a split between the two levels here, so I've got inner and outer faces. Now I'll just smooth that down a little bit to make what we're looking at a bit clearer. So what I'm curious about, and it's difficult to tell just by looking, is whether this is still one continuous object or whether it is now two objects or more than two objects knitted together. Now the way you can tell this is using the separate command. So use the separate and watch the geometry graph and see if it falls in two, but it doesn't. So this is one object, and I suppose I could have detected that by, if I select faces for example and then use the plus key, I can sort of propagate that around and watch the flow of the selection faces around the object until it finds its way back to here, which is the underside of this other face. So what I can conclude from this, if I put a port in this face that connected between these two, because it's one object, it wouldn't affect its, I don't know what the word is, topography. It's still one object. But if it was two objects, it might link it into being one object. But there's no guarantee of that. So I'm going to go on to the next shape, which is tetrahedron as a cube. Okay, that's the next one. It's a little bit bigger. I'll zoom back a bit. I'll select the corners again. So this process is remaining the same. Bevel those down until I've got a little bit of a line there. Select that little bit of a line. No, I shouldn't have done that. The process is the same. I just can't remember what it was. So select this triangle, identical, and I'm intruding at this point. So I just need to intrude and bear in mind this rectangle is going to become a square. So select this little bit of a line on the outside. Now I've intruded. Identical, loop, right click, circularize, stop that, right click, and loop cut. Find the deselected one, hide that, press space to deselect the rest, select one of the squares, bring the missing bit back, press identical, right click and rotate normal and 45 degrees, and then weld and then select it all and do Sabian subdivision. Locate these ones that are passing from one side to the other. I think it's possible to get it wrong and select the wrong bits like this, so that will be the wrong bit, and then it doesn't work. It sort of breaks because those can extend right round themselves, and it sort of gets, anyway, that's by the by. I need this one. Don't get distracted or digress unnecessarily. Okay, so I've got that one, and those are the correct ones, and then I intrude that so it splits it in two and then smooth it down. So, same question again on this one. Are we dealing with more than one object, or is it all one thing? I'm going to use separate again. Find out. Okay, so it's not separated, so now we'll do the faces. I really like this effect for some reason. Be a good one to animate if I could figure out how to do any animation. So it goes around and around and around and around and around, and what's the last to get selectable? This one and the one at the bottom. So all one object up to the next level. So porting again wouldn't make any difference to the geometry of this. It just make it a bit of a stronger shape if you were printing it out or something like that. So octahedron, right, which is closely related to the cube, and I select these outer points and bevel them down, and then remember at this point to intrude and not forget that bit, so intrude that a bit. Okay, and then press space, get the edge, select one of these outer edge bits, identical, loop, circularize, stop there, right click, loop cut, find the deselected one, hide that, press space, select one of these squares, bring that back in, identical, right click, rotate normal. Okay, it's 45 degrees, select it all and weld, and then select it all again and do Sabian subdivision. Locate the ones that are running around from one face to the other, so where have you? Right, G, identical G, now that looks about right to me, and then intrude and smooth, and then say, what do we think? Well, it looks like the cube, so you might reasonably expect that it was one object. However, I've done this test before, and I did it on another object in another video, and I happen to know that it is in fact two objects. The thing about this, though, is that the two parts, so if I select this part, you'll notice that the other face opposite, if it was ported through to that face, if I made a hole that just connect these two bits together, they wouldn't make any difference, because the two faces opposite each other are part of the same object. So if we do this bit here, and it's only going to do it on half now, use the plus key to spread it around from one side to the other, you can see how it loops back finally to itself. So it takes quite a long path, but it does get back to itself. So that was the, what was that? I'm doing it in two parts. Okay, that was the octahedron. So let's go to dodecahedron now. So the dodecahedron, I've tried this, and it's a little bit tricky to do this one, because I beveled this one out here, but these sides are quite big, and the areas to intrude are small. So if I'll have to intrude it more maybe and leave a very small gap. It's difficult to tell. I'll just bevel that down again. So I'll make that face there quite small, so it leaves the area I'm intruding large. Go in a bit, but not too far, because when this becomes a cube, it'll shrink, square that'll shrink that hole. So select the edge tool, select one of these little bits, go identical, and loop, and right click and circularize, and stop there, right click and loop cut. Find the deselected one, hide it, press space, find a square, put it back, press identical again, right click, rotate normal, and do the weld, and then do Sabian subdivision. Locate the ones that are running from object to object, so that's that one, G, identical, G, and there we've got them selected, and then intrude that bit, and then select the entire object, and smooth. So, looking at this, again, very difficult to tell whether it's still one object, and presumably there's some kind of mathematical way you could determine that. There was some kind of rule hidden in here somewhere that I'm not aware of, which is why I'm just testing it empirically. So I'm going to select the entire object and separate it, and it remains one object. So I'll try not to crash wings, but let's do this experiment again and see how the pattern flows in and out. So where's it going? Is it going to end up? Is it going to end up? Oh, I've lost track now. No, there's a few places which are sort of there's a last bit. Maybe that's the opposite edge where I started. I'm not sure now. It would be logical that it should be, I suppose. It's all right underneath itself. So interesting flow on the surface there. Now, I wonder if I can select the wrong one on this one, because I tried to do it on the cube and it wasn't very successful. It's getting confusing. If I select this one here, which is the wrong one, that's the correct path, and use G, and identical and G, and then I, not bevel, that's the wrong command, come back, Control Z, face, I'll just intrude that. So this is what it looks like if it goes wrong. If you've intruded the wrong bit, you get all these separate things that loop back on themselves, like so. So that's how you know when you've got the wrong path. So there's the wrong path and the right path, and the right path goes from object to object. Okay, right. Pressing on, because I'm losing command of my own voice here. Need coffee. Last but far from least, the Icosahedron. So the same process again. Select a vertex, press I for identical, right click, bevel it down, but not all the way, so you've still got these little connecting edges. Intrude this somewhat, select the edge tool, so edge tool, and go identical and loop, right click, circularize, stop there, and then loop cut, find the deselected one, hide it, press space, select one of these inner squares, bring that back in, press identical, whoops, that's not identical, that's identical, and then rotate normal, 45 degrees, select the entire object, weld, so it puts the corners back together, select the entire object, do Sabian subdivision, press space, locate the correct edges, go G, identical G, face tool, and intrude, and then select the entire object and smooth and smooth. So looking at this is quite a complicated thing to look at, difficult to tell whether it's more than one object. So right click and separate. 5 separate components, which is a bit of a surprise perhaps. Now the thing about this though is that the ones that underneath that would be connected by a port are not the same object that's selected, and because there's 5, the port connects one level to another, which would be a sort of a 2 symmetry. So 5 is not divisible by 2, so if I connect that to that with a port, and then that one to that one with a port, and then you would have well, this one to that one connected with a port, and finally then this one to that one. If you put ports in this, it would become one object. So at the moment it's 5. So I'm just going to go back, right back, just go back to where I started. So there, and put the ports in. So select one of the faces and inset that face. Now the reason for doing it at this stage is because it generates extra edges, and that could change the overall geometry. So the ports have to go in first in this case if you want this to work. So select corner, identical, and then bevel that down. Now your limitation on beveling here is when these faces meet these inner triangles. So this obviously ended up a bit longer. Now select the triangle, identical, intrude. So that triangle is now going to become the port. So just intrude in a bit. In the case, select this edge, edge tool, deselect for space, space, edge, edge, identical, loop, circularize as before. No, that's not worked, has it? The loop's not gone all the way around. Loop a few times more. Now circularize. That's better. Then right click and loop cut. Locate this one. Hide it. Select that square. Bring that back in. Go identical. Right click and rotate normal. 45 degrees. Select the entire object and weld. Select the entire object. Do Sabian subdivision. Okay, it's a bit clearer now which ones these are. So that's the one that links from object to object. Go G identical a few times. Just make sure you've got them all, and then intrude. So intrude that now, and then we'll smooth it down a couple of times as we did before. So the byproduct of this should be that these, and I've not tested this. This is just, we're working on theory now, but I think it was fairly evident. It's now one object. So if I now select the entire object, right click and separate, it's all one object, so it wouldn't fall apart. It wouldn't, if you were to print it, it wouldn't just like be 5 rattly objects fitting inside each other. These ports here, unlike the other 4 examples, would make a difference. It would change the object from being separate components to being a solid thing. Whereas with the Octahedron, as in the other video I showed you, that one you need to sort of put little bits of webbing in to stop it from falling apart, because the opposite faces, there and the other one opposite there, belong to the same object to start with, and so they're sort of like 2 independent in that way. So there you go, a rather long-winded, and I have no idea whether this experiment has any purpose at all. It was just something that I got interested in, and I thought I would record it, so if the question arose again, and I do tend to forget these things, then I can go back and study my video and see what I did. So anyway, if anybody else finds that interesting, that's really cool. Otherwise, I'll be the only person watching this. Okay then, that's the end of the video.